Welcome to qnawire.
Now we have this system where we have a block sliding down this incline. The incline is at 36.9 degrees with the horizontal. And it's connected to a rope that is then spooled around a pulley here. And so this thing rotates as this thing moves down. So let's see here. This thing, the block here, weighs 5 kilograms. There's a coefficient of kinetic friction of 0.25 between the block and this ramp. This pulley here weighs 25 kilograms, and we're also given its mass moment is 0.500 kilogram meters squared, and its radius is 0.2 meters. Again, we're assuming no slipping, so that the acceleration of this guy equals this radius times the angular acceleration of this pulley. So we draw a free body diagram, and of this pulley here, we have just the reaction forces at the pivot point. But again, where those go through the pivot point, so when we take moments about that, they don't show up. So they don't actually come into our problem. If we wanted to figure out what they were, we could take force balances on the x and the y direction here. But they never asked for that. So T here creates a positive torque, T times R. So it's always perpendicular. And then that equals J times alpha of the angular acceleration of this pulley. Then for this guy here, in this direction, we have no acceleration. So we have N equals W cosine of theta. So this is the component of the weight perpendicular to the ramp. And in this direction, we have minus the friction force, minus the tension, plus the component of weight along the ramp equals the mass of this guy here times its acceleration. We can use our, let's see here, I guess I didn't write it down, use our relationship for the friction force, because everything we're assuming is moving. Use that, put that in here, put this into here, and we'll get this term. The weight is just mg, and so this becomes this. Now T, we can solve for T, is, and then substitute this for alpha, so we get T equals JA over R squared. And then we can just do a little algebra here and solve for A. So we get A equals G times this quantity divided by 1 plus J over M1 times R squared. So a couple of things we can note here is that if J is 0, then this comes down to, A is this thing. And then we've probably seen that in a previous problem. So that if there's no pulley here and this is just sliding freely down here, then we get the solution that we normally would get if we just had a block sliding down a ramp with friction. Let's see here. What else can we say? If M1R squared gets really big compared to J, then this thing gets really small, and again we get a similar situation as just that there's effectively no pulley. Obviously, if we get rid of the friction, that makes sense. If it, and then that A decreases as the friction increases, and obviously, at some point A is going to go to 0, and then basically then we have static case. It's never going to be negative, in physically. And so plugging in all the numbers, we get 1.12 meters per second squared. And then they ask for what the tension in this rope is, so we know that that is just JA over R squared. Plugging everything in, we get that is 14.0 newtons.